Today we'll be covering Chapter 1, The Science of Nutrition. In your lifetime, you will consume around 60 tons of food over the course of 70,000 meals and numerous snacks. Research over the last 50 years has shown that foods we eat affect your health and longevity. A healthy diet, which means eating many fruits and vegetables with frequent exercise, can prevent and treat many diseases. Eating a poor diet is a risk factor for many common life-threatening chronic diseases. We also know that we live longer than our ancestors, and preventing these chronic diseases has become even more important now. In today's world, many people want to know what's the best diet, which nutrients are helping you stay healthy or prevent diseases, should you take a supplement, and we are going to discuss all of these things over the course of this semester. In this chart, you will see the leading causes of death in the United States. As you can see, diet plays a role in the development of most of the leading causes of death. The majority is coming directly from three different areas. 23% from heart diseases, 23% from cancer, and the largest at 25% comes from accidents and adverse effects. You'll also see 5%, 6%, 5%. All of these little percentages come from diabetes, influenza, pneumonia, kidney disease. So it makes up a lot of the percentage. The American Medical Association defines nutrition as the science of food, the nutrients and the substances therein, their action, interaction, and balance in relation to health and disease, and the process by which the organism ingests, digests, absorbs, transports, utilizes, and excretes food substances. When we're talking about the organism, we are talking about humans in general. Food provides the nutrients needed to fuel, build, and maintain all body cells. To be considered a nutrient, a substance must have these characteristics: have a specific biological function, cause a decline in normal human biological function, such as the normal functions of blood cells if removed from the diet, and restore normal human biological functions that were impaired by the absence of that nutrient. Nutrients are essential, meaning the body cannot make these. So these can be broken down into two categories: energy-yielding and non-energy-yielding nutrients. The energy-yielding nutrients that are essential are carbohydrates, protein, and lipids. If you see the term lipids, that means fat. Another energy-yielding nutrient that is not essential to your body is alcohol. The non-energy-yielding nutrients are vitamins and minerals. These include water-soluble and fat-soluble vitamins, and also the major and trace minerals. You have three different functional categories for nutrients. Those that primarily provide energy include carbs, protein, and lipids, also called fat. You will see these expressed as a kilocalorie. Those that are important for growth and development and maintenance once growth stops. Those that regulate body processes and functions, and we can specify nutrients into macronutrients, meaning those nutrients that are needed in large amounts. Those are carbohydrate, fat, and protein. The micronutrients are those nutrients that are needed in smaller amounts, and they include vitamins and minerals. This table is showing you the functional categories of nutrients. So if we're looking at the ones that provide energy, it's most carbohydrates, proteins, most lipids, which includes fats and oils. They're all going to provide energy for your body. The nutrients that promote growth and development include proteins, lipids, or fat, some vitamins, some minerals, and water. And those that regulate body processes are proteins, some lipids, some vitamins, some minerals, and also water. Carbohydrates are composed mainly of the elements carbon, hydrogen, and oxygen. Fruits, vegetables, grains, beans, and sugars are the primary source of carbohydrates. The main two types of carbohydrates include simple and complex. Simple carbohydrates are small carbohydrate structures called sugars. These include glucose, fructose, and galactose. You can combine glucose and fructose together to form sucrose, which is also known as table sugar, and all three of these simple carbohydrates can combine to form different disaccharides. Some of these sugars can combine together to form polysaccharides or complex carbs. Those are long chains of glucose, fructose, and galactose together to form these complex carbohydrates. Glucose is the major form of energy in most cells at 4 kilocalories per gram. Lipids are made of carbon, hydrogen, and oxygen. Lipids consist of fats, oils, and cholesterol. The term fat is referring to lipids that are solid at room temperature. You can think about butter when we're talking about the term fat. The term oil is referencing lipids that are liquid at room temperature. These are oils like olive and canola oil. And the term triglyceride is the major form of fat in foods, and it is the key energy source in the body. These molecules are composed of a glycerol head attached to 3 fatty acids, and there's a picture of this in your book, and that's where the term triglyceride comes from. There's 3 fatty acids, so it's a triglyceride. We can break down lipids into 2 categories, saturated and unsaturated. This is based on the chemical structure of their dominant fatty acids. This will determine whether the lipid is solid or liquid at room temperature. Saturated lipids are solid and come from animal fats. This type of fat can raise blood cholesterol, which clogs arteries and eventually leads to cardiovascular disease. Unsaturated lipids are liquid at room temperature and typically come from plant oils. Unsaturated fats are healthier than saturated fats. 2 specific unsaturated lipids are essential to the body. These are linoleic acid and linolenic acid. The term essential means it has to be consumed from the diet. Some foods contain trans fatty acid, which is when unsaturated fats have been processed to change their structure from the cis form to the trans form. We're going to talk more about this in the lipids chapter, but you primarily find lipids in fried foods like donuts and French fries. We are referring to trans fatty acid lipids, and you also find them in baked snack foods like cookies and crackers, and in solid fats like stick, margarine, and shortening. So you want to lower your intake of these foods because of their terrible effect on your health. Proteins are also composed of carbon, hydrogen, and oxygen. There is one key difference to protein than the other nutrients. They contain the molecule nitrogen. Proteins are the main structural material for the body and make up bone, muscle, enzymes, and blood. The smallest form of protein is called amino acids, and proteins form when amino acids bond together. There are 20 common amino acids, 9 of which are essential for adults, meaning you have to consume them from your diet, and 10 of them are essential to infants. If we're talking about the calories associated with the macronutrients, here is the list, and make sure you put a star by this, memorize this. Carbohydrates have 4 calories per gram. Protein also has 4 calories per gram, so they are the same. Alcohol is 7 calories a gram, and fat has 9 calories a gram. So fat is going to have your highest energy density of the 4 macronutrients. Vitamins have a wide variety in their chemical structure. They can contain the elements carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and others. Vitamins do not have energy or calories associated with them. Instead, vitamins' main function is to allow chemical reactions to occur in the body. Some of these reactions are involved in helping release the energy from carbohydrates, fat, and protein. The 13 vitamins are separated into 2 categories, fat-soluble and water-soluble. Fat-soluble vitamins include A, D, E, and K, and your water-soluble vitamins include vitamin C and all of the B vitamins, which include riboflavin, niacin, thiamine, B6, B12, pantothenic acid, biotin, and folate. All of the nutrients we have talked about so far are complex organic compounds, but minerals are structurally very simple inorganic substances. Inorganic substances generally do not have carbon atoms bonded to hydrogen atoms. Minerals typically function in the body as groups of one or more of the same atoms. So we're talking about sodium or potassium. But because they are elements, minerals are not destroyed during cooking. Minerals do not have any calories associated with them. And you can categorize them into major or minor minerals. So your major minerals, you need more than 100 milligrams per day. This would be sodium and potassium. Your minor minerals, you need to consume less than 100 milligrams per day. These would include iron and zinc. Just like your minerals, water is also inorganic. There's no carbon. The formula for water is H2O. There's 2 hydrogens to 1 oxygen. We need water in the largest quantity out of all of the nutrients. And water is used as a solvent, a lubricant, medium for transporting nutrients, and it is also a byproduct of metabolism. Phytochemicals are plant components found in fruits, vegetables, legumes, and whole grains. Zoochemicals are components in animals that are physiologically active. These are not essential to your body, however, they provide many significant health benefits. One of the biggest health benefits are the effects of helping protect the body against cancer. So when you're thinking phytochemicals and zoochemicals, your main thought should be protect against cancer. Some phytochemicals and zoochemicals also reduce the risk of cardiovascular disease. We are still in the research stages of learning about phytochemicals and zoochemicals and their interactions. If we're looking at a multivitamin and mineral supplements, they do not contain phytochemicals or zoochemicals. You can only find that in fruits and vegetables that are eaten. This is why we recommend eating fruits and vegetables rather than a supplement. So let's review. We have 6 classes of nutrients. We have carbohydrates, protein, lipids, which is known as fat, vitamins, which include water-soluble and fat-soluble, minerals, which include your major minerals and your minor minerals, and then we also have water. Calorie is a term often used to express the amount of energy in foods. Technically, a calorie is the amount of heat energy it takes to raise temperature of 1 gram of water 1 degree Celsius. Because a calorie is such a tiny measure of heat, food energy is expressed in kcal or kilocalorie. This is referring to the amount of heat energy to raise the temperature of 1 liter of water 1 degree Celsius. When we are referring to calories in food, we are talking about kilocalorie or kcal. We measure the kilocalories in food using a bomb calorimeter, and we'll discuss this in another chapter. And we can also do this by adding the kcal per gram of each macronutrient by the grams in the food. For example, if we're looking at energy sources and uses of 1 hamburger, we'll take carbohydrate, fat, and protein. And in that hamburger, there's 39 grams of carbohydrate. And because we know that there's 4 kcal per gram of carbohydrate, we'll multiply that together to equal 156. For fat, we know there's 9 kcal per gram, and there's 32 grams. So we multiply that together to get 288. And then for protein, there's 30 grams, and protein is 4 kcal per gram, so that's 120 calories. So that's that slide I told y'all to put a star by. And then we'll add those numbers together, and now we know that this hamburger has 564 calories. If we look at an 8-ounce pina colada, it has all 4 categories of nutrients that provide energy: carbohydrate, fat, protein, and alcohol. Carbohydrate has 4 kcal per gram, so we'll multiply that by 57, giving us 288. There's 5 grams of fat in the pina colada times the 9 kcal per gram, gives you 45. Protein, there's 30 grams, and we're going to multiply that by 4 because protein has 4 kcal per gram. And then for alcohol, we're going to do 23 grams because there's 23 grams of alcohol times 7, giving you 161. This is going to total at 438 calories for an 8-ounce pina colada. If we're talking about the influence on diet, there's 2 terms that are different from each other. There's hunger, which is the actual physical need for food, when your body's physically hungry. And the word appetite, which is a desire to eat certain foods. The main influence on the foods that are eaten is appetite, so the foods that you like to eat. So your appetite's going to depend on food flavor, texture, and appearance preferences. If you like spicy food, if you don't like soft, mushy food, it's a texture issue. Maybe your appearance of foods, things can't touch each other. It has to visually look appealing to you. Your culture, where you're from. We know here in South Louisiana that we eat differently than up north, and we prefer different foods, and that goes for every culture. Your lifestyle, how busy you are in your life. Do you have to eat out at restaurants? Do you have time to prepare meals? Routines and habits. So what routine do you have as far as cooking? Food cost and availability. Can you afford strawberries when they're out of season compared to when they're in season? Can you afford the better meats for you, or do you have to choose for the ones that are on sale? Is it available in your location? Environment is including your surroundings and experiences. So in America, we have a lot of restaurants that provide high calorie, high fat foods. Food marketing, so how is the food being marketed to you? And then your health nutrition concerns, knowledge and beliefs. So do you know about what foods are healthier, which ones you should avoid? And hopefully you'll learn that by the end of this course. So this is one of my favorite things to show everyone, is the marketing that they do to target children and adults as well. But if we're looking at these pictures, you can see the eyes, and I'm going to circle them for y'all. What do you notice about them? I want you to imagine that you're a child again for a moment, and you're in a buggy or you're walking alongside your parents, and these are like on the middle shelf and you have to look up to them. Marketing is brilliant with this because they make eye contact with the people or the children beneath them. So your Lucky Charms leprechaun, whenever you look at him, you're going to make eye contact with him, and then the child's going to be like, ooh, I want that cereal. So they heavily market all these cereals towards children with the eye contact with their favorite characters. If we look at these fruit snacks, they have Paw Patrol, so we can target to children who love Paw Patrol. Even though it's assorted fruit flavored snacks, you got to always make sure you're checking to see how they're flavored. Are they made with 100% fruit or not? And we're looking at adults lose up to 7 pounds in 2 weeks in big bold print, and then they kind of show you the food, but they're calling this the 5-day weight loss kit. Everything's included in one box, but they can really target those individuals that are wanting to lose weight. The body's nutritional health is determined by the sum of its status with respect to each nutrient. So there are 3 general categories of nutritional status. There is desirable nutrition, undernutrition, and overnutrition. The term malnutrition can refer to either overnutrition or undernutrition, neither of which is beneficial to good health. So if we're talking about undernutrition, this occurs when nutrient intake does not meet nutrient needs, causing surplus stores to be used. So if they have any extra nutrients on their body in the form of fat, those stores are going to be used to continue to fuel that person's body. Desirable nutrition, or also known as optimal nutrition, is the state in which the body tissues have enough of the nutrient to support normal functions, as well as to build and maintain surplus stores that can be used in times of increased need. So this person is getting exactly what their body needs, not anything less, not anything more. Overnutrition is the consumption of more nutrients than the body needs. In the short run, for say like a week or so, overnutrition may only cause a few symptoms such as intestinal distress from excessive fiber intake. So if you're increasing your fiber intake without increasing your water, it can cause excessive bloating, gas, etc. But let's say we go beyond that week and we continue to have excessive eating, or more than what your body needs. The levels of some nutrients in the body may increase to toxic amounts. So if we're talking about vitamins, it could have negative effects on children, women, and adults. But if we're talking about the most common type of overnutrition, which is excess intake of energy, this is going to lead to overweight and obesity. And then in turn, someone who is obese can possibly have other serious chronic diseases, such as type 2 diabetes, certain forms of cancer, and cardiovascular disease. Health promotion and disease prevention have been the public health strategies in the United States and Canada since the late 1970s. One part of this strategy is Healthy People 2020, and in Healthy People 2020, 2030, we had 2010, it's 10-year goals, mostly nutrition related, for high quality, longer lives. So some examples of some goals in Healthy People 2020 would be to increase the proportion of adults who are at a healthy weight. So they're having that optimal nutrition or desirable nutrition. Another one would be to reduce consumption of sodium in the population ages 2 years and older. A nutritional assessment can help determine how nutritionally fit you are. Generally, these assessments are performed by a physician, often with the aid of a dietitian, or the dietitian will do it by herself. A nurse can also do this sometimes. Included in this is background and history, such as medical, so current and past diseases and surgeries, body weight history, current medications, family medical history, health conditions, family conditions, that's all in the background history. We'll look at nutritional factors, such as anthropometric assessments. This would include someone's height, their weight, body circumferences, skin fold thickness. These are reliable, easy. If we're looking at skin fold thickness, it really depends on the person's knowledge of how to use the caliper to accurately measure someone's fat using skin fold thickness. We have biochemical assessments, which is the measure of the concentration of nutrients and nutrient byproducts. So this would be a lab draw, feces, urine, blood, and we're going to look at the nutrients in all of those. The clinical assessment is the physical evidence of diet-related diseases. So looking at someone's skin, looking at their eyes, tongue, their ability to walk. These are things that you can physically see if something's wrong. We'll also look at a dietary assessment. So how often a person eats certain types of food. This would be a food frequency questionnaire. The types of food eaten or a food history. Typical intake, so 24-hour recall. If we do a 24-hour recall, we're making someone recite everything that they ate and drank within one 24-hour period. We can look at the environmental assessment. So what is this person's education level? What is their economic background? What is their class? Are they low income? Are they middle class? Do they have a lot of income? But all of these together are known as the ABCDEs of a nutritional assessment. So A is anthropometric, B is biochemical, C is clinical, D is dietary, E is environmental, and A is assessment. So let's look at an example of using the ABCDEs. If we're looking at someone's anthropometric measurements, and maybe they're low weight for height, they had a recent 10-pound weight loss, there's muscle wasting in the upper body. So now we're going to look at biochemical, and there's low amounts of the vitamins thiamine and folate in the blood. Clinical, they have psychological confusion, skin sores, and uncoordinated movement. Dietary, they're consumed mostly alcohol-fortified wine and hamburgers for the last week. Environmental, they're currently residing in a homeless shelter with $35 in their wallet and they're unemployed. So the assessment of this would tell you this person needs professional medical attention, including nutrient repletion. So they need certain nutrients so they can hopefully get on the up and up, essentially. There are some limitations to looking at someone's nutritional health status. It can be helpful, but it's important to recognize these limitations. So it can take a long time until these signs and symptoms show. The Many signs and symptoms of nutritional deficiencies that occur initially, such as diarrhea, skin conditions, and fatigue, they're not very specific to each certain nutrient. So if we're looking at something that would have a long lapse between the development and clinical evidence, cholesterol. If you intake a diet high in cholesterol, it could take many years before you see the negative effects of that. Or osteoporosis, not consuming enough calcium, and so you're going to have weaker bones later on in life, but it takes a long time, many years, sometimes decades, for these symptoms and signs to show. As a dietitian, we use the nutrition care process, and physicians can also use this, but there's 4 steps to this. The first one is conducting a nutritional assessment. So all those A, B, C, D, E's we talked about, the nutritional assessment. Then diagnosing a nutrition-related problem. So it uses your nutrition history and assessment data to determine your specific nutrition-related problem. Then we will create an intervention. So it formulates a diet plan tailored to your needs. We're going to monitor and evaluate the progress. So follow-up visits to track your progress, answer questions, keep that person motivated. And then a dietitian is also going to consult with their physician so they're up to date on the information as well. You want to be skeptical of health practitioners who prescribe very large doses of vitamins, minerals, or protein supplements for every single person. So how did we learn all this information about nutrition? Where did we get this knowledge? To sum it up, research. And if you've ever looked at the scientific method, which hopefully you have, you know that they have all these different steps to learn and come up with a conclusion. So the scientific method has an observation. So you make an observation about something, and then you're going to come up with a hypothesis. So your hypothesis, you're hopefully wanting it to be true, and you can find the information to prove that. So then you have to perform controlled experiments. You're going to have a group, one that probably has a placebo, which they're not actually getting the treatment, and the other one which is, so you can gather data and then propose a scientific theory or law from that. The scientific method requires an open, curious mind and a questioning, skeptical attitude. Scientists must not accept proposed hypotheses until they are supported by considerable evidence, and they must reject hypotheses that fail to pass a critical analysis. So let's look at an example. Step 1. Observations made and questions asked. In the mid-1950s, physicians note that in a short-term experiment, people eating a low-calorie, high-protein diet lost weight more quickly than people eating a low-calorie, high-carbohydrate diet. So there's our observation. Now we're going to have the hypothesis. Step 2. Our hypothesis is low-calorie, high-protein diets, such as Atkins or Zone diets, lead to more weight loss over time than low-calorie, high-carb diets. So now we go to step 3. Research experiments conducted. For 1 year, researchers followed people assigned to either a low-calorie, high-protein diet or a low-calorie, high-carbohydrate diet. At the end of the study, weight loss did not differ significantly between the two groups. So now we go to step 4. Findings are going to be evaluated by other scientists and published. A peer review indicated that the study was conducted in an unbiased scientific manner, and the results appeared valid. This study was then published in the New England Journal of Medicine in 2003. So now we're going to have follow-up experiments conducted to confirm or extend the findings. So there was another study published in 2005, 2007, and 2012, and they all pretty much came up with the same thing, that there was no difference in weight loss from these two diets. So step 6 is to accept or reject the hypothesis. So based on the current research, the hypothesis is not accepted because we were able to show with all these different studies that the two diets pretty much had the same weight loss. There was no significant change. So once again, scientists must not accept proposed hypothesis until there's considerable evidence. So now I want to tell y'all about some scientific research that occurred in the 15th and 16th centuries. So whenever we were traveling across the ocean to the United States, sailors on the ships would have very few fruits. And so they discovered, after many people died, a researcher or a doctor on board said, let's see what happens when I give all these different individuals different items to see what we're missing. He figured out they were missing some dietary component. So the experiment was to give one group salt water, one group vinegar, one group cider, one group citrus juice, and then liquid to another one. So all these different people were getting these. And at the end of it, they discovered that citrus juice prevented scurvy from happening. But the consequence of that was that everyone else wound up dying or becoming very sick. So this type of research would not be approved today, but it is interesting to see what used to occur in the 15th and 16th centuries. Human experiments are the most convincing type of research, but because most of it can become unethical in humans, like depriving someone of a certain B vitamin to see the negative effects, we can't do this on humans. So most nutrition recommendations actually come from lab animals or rats. In order to perform a human study, they have to have prior approval, and the research has a review board. They review everything about this study to make sure it's ethical, there's no violations occurring, and the patients or the participants have to know the risk and the benefits, every single piece of information about this study or this piece of research. And they can actually drop the research at any point in time. Once they sign their consent form saying they want to participate, it doesn't matter if it's the next day, they can drop the study. We have different types of studies, one being a case control study, and this is when scientists compare individuals who have the condition in question, so that would be your case, such as lung cancer, with individuals who do not have the condition, which would be your control. So that's why it's called a case and a control. The next one is a blinded study. So we have single blind, which is when you have an experimental group which is receiving treatment and a control group receiving a placebo. It's called single blind because the participants don't know which group they're in, but the researchers do know which group they're in. Double blind is the most accurate, most reliable type of study because both the participants and the researchers don't know who is in the treatment and in the placebo group. The only people who know which group of participants is in the treatment and placebo is an independent third-party holder, and they're the one that has all the data until the study's completed, at which point it becomes unblinded so the researchers can see what the effect was. There's a term called the placebo effect, which occurs when the control group participants experience changes that cannot be explained by the action of the placebo they received. These changes may be linked to a treatment that is working or a desire to help researchers achieve their goals. Overall, it's critical for researchers to take the placebo effect into consideration when interpreting research results. If we're talking about peer review, this occurs before research is published. Another group of scientists familiar with the subject will review the study, make sure that the results are unbiased, there's objective findings, and that the information is also reliable. This is funded by government, nonprofit organizations, drug companies, private industries, and there's strong expectations from these peer-reviewed journal articles. When completing research, you always want follow-up studies. A single experiment is never enough. We need different circumstances, different ages, different information, and hopefully we can get the same results. And if you have all these different experiments with varying circumstances, then you know that that information is accurate, and we should always avoid rushing to accept new ideas. A systematic review is on a specific topic, and it summarizes major findings from different studies. So we can take maybe 15 different studies done and write a paper on this and review all the different information and write conclusions based on that relevant research. Nutrition claims often appear in media stories and in advertisements. Sometimes it is difficult to discern whether the claims are true or false. So here's some suggestions that can help you make helpful and logical nutrition decisions. Step 1. Apply basic principles of nutrition. Are there any inconsistencies? So think about the things that you've learned so far and that we're going to be learning by the end of this course. Do you see any inconsistencies? Number 2, be wary of yes answers to the following questions. Are only advantages discussed and possible disadvantages ignored? So they haven't given you one single bad thing about this product. Is this a new or a secret scientific breakthrough? There's no such thing as a secret scientific breakthrough. If it's new, typically they're going to have some previous study on it. So you want to be wary of this term secret. Are claims made about curing disease? Do the claims sound too good to be true? As with most things, if it sounds too good to be true, it is. And is there extreme bias against the medical community or traditional medical treatments evident? So they're saying the medical community does not agree with this, but I'm here to tell you that this works. Examine the scientific credentials of the individual, organization, or publication. Where did they go to school? What is their degree in? Do they have a degree? Who's their organization? Are they sponsored for this? Is it in a peer-reviewed journal? Note the size and duration of the study. So sometimes these new products will have done a study, but is it on 2 people over a 3-week period? That's not accurate. The larger the size of the study, the more participants, the longer it went on, so maybe 2 or 3 years, the more reliable the information is. Be wary of press conferences and other hype regarding the latest findings. If it's mostly friends and relatives and other people saying, yes, this worked, but there's no real evidence behind it, you want to be wary of that. If we're looking at claims on nutrition products that say increase muscle growth, boost energy, reduce body fat, improve brain function, there's very few evaluated by reputable scientists. You will see, some of these claims on nutrition products, a lot of them will not be evaluated. And the issue with supplement facts is that the FDA does not have to prove that it's safe. Instead, the FDA has to prove that it's unsafe. And so you'll see this statement right here on nutrition facts labels. This statement has not been evaluated by the Food and Drug Administration. This product is not intended to diagnose, treat, cure, or prevent disease. So just be aware of this when you're taking a supplement, looking at supplement facts, that the FDA does not monitor this until it's proven unsafe.